Let us do some exercise just to sharpen our understanding about pointers and the relationship between pointers and array. We define or we declare an array of integer. I'm giving random values, and then let us declare a pointer to integer, and then we immediately assign to one of the element. Now, in the slide, the assignment was something like this. If we are doing this, we are assigning to the first element in the array. But I don't want to do that because this is already shown in the slide. I want to manually point to the second element, which is index 1. If you still recall, in array, index 1 is the second element, which is 3. But if we're doing this, we need to manually put ampersand. You see just now, if I give it just a name, there's no error. There's no red squiggly underline. But if I put index, I get an error until I give the ampersand sign to tell that I want the address of the second element or the index 1. Okay, I'm doing this because I want to show that we can also do subtraction. Let me print. This is second element, percent D. So don't forget we have to dereference. That's it. Save. Compile. So I get 3, which is correct. Then I want to do a decrement first. My ptr minus minus. Then if I decrement, meaning now I'm pointing to first element. But as you can see here, the expression in the pointer is still the same. This is the power of pointer. You do operation on the pointer, but then when you want to dereference, the dereferencing is the same, which means you can sort of point the pointer anywhere you want, but the process of getting or reading from it is the same. So first element is 5, it is correct. Then I want to add 2. Add 2 from the first element, meaning 1, 2, it is the third element. So it's correct, third element is 0. Next exercise is, I want to show you something that is not really standard, but it is good enough to increase your understanding about address operation. What I want to show is, what if we do not put this indirection operator, the asterisk, address of second element. Now, don't indirect, we print the pointer content itself. This will give us the value of the address. Then I want to print all addresses. This one I decrement by 1 and then add by 2. So you can see here, the value of second element is 3, but the address is this. It's a big number. Then we are going down from second to first. You see, the value of the pointer does not go down by 1. Even though you go down by only 1 point, second to first, but the value in the pointer goes down by 4 units because our array is array of integer. One integer is 4 bytes, so going down one pointer from one integer to the one before it will reduce 4 unit or 4 bytes. And then when we add 2 to go to the third element, we actually add 8 to the address. And then another interesting point for you to see is that if we run again, we have a totally different address. The reason is because the first run, the program asks for address for this array, and the operating system, Windows, give this set of address. Then when the execution stop at here, it's like we are closing the account in a bank. When we open again, when we run again in Windows, it's like we are opening a new account. So the account number is totally different, but the number of differences between second and first, for example, is still 4 byte, and the first and the third is still 8 byte. So the concept of pointer arithmetic is still the same, but you need to know here that every time you run, you will almost definitely get different set of address. And if you run this on your own PC, you can never get the same address that I have here. You can try this at home.